All right, I'm going to get started. This is going to be real-time mobile MMOs with AI. My name is Terry Ryan. I'm a developer advocate for Google. If you want to get in touch with me, on all the bottom of all the slides is my Twitter handle. I tend to respond quicker to that than to most other forms of communication. So how many people here would have a huge problem if I showed code? Would be really angry if I showed code? How many would be happy if I showed code? All right, good. So the other thing is, you guys all saw that Robert, were you guys here for Robert's, and he did the live demo with the thing and the video and basically sucked up all the good karma for demos, right? So I have live demos. I'm actually going to ask you guys to participate. You can plug in on your phones and play around with some of the stuff I'm going to be showing off. But hope, let's hope that the demo karma bears out and stays. Hypothetical situation. You've got a game. You've got a game that you want to build, that you want to roll out to people, and you need it to run on mobile, right? This is not that shocking or uncommon. This is a pretty thing that happens quite often. Now, for the purposes of this talk, I'm going to be talking about gaming, right? But real-time communication that I'm going to be talking about applies more than just gaming, obviously. But this creates a very solid use case to sort of talk about and go through. Okay, so you got an idea for a game. You want it to run on phones. So you talk to people and you're like, all right, well, we'll just hook it up to a cloud, right? And a lot of times the management level will say, yeah, just fine. Because once you have more than one person in that game, I guess you could have mobile peer-to-peer, but I guess you could also shoot yourself in the face, right? Because that would be just as enjoyable. So you go, okay, we'll put it in the cloud. And you have this idea of the cloud as this big blue, in this case, a big blue box, into which you put things and things just happen. But the truth of it is, behind the covers, you start saying, well, all right, so I need to put all the game states somewhere, so that's got to be in a database. And then I probably need some sort of front end to sit in front of the database and kind of convert stuff from the game into the database. And then maybe you need some storage, some CDN hosting, right? So you say, okay, I've got sprites and whatnot, I need that hosted. You need some processing, and so you build some other servers for that. So you end up building a lot of stuff, right? And it's great. No offense to the rest of Google Cloud Platform. We love that you want to build your infrastructure here, but I just want to build a mobile game became an infrastructure project. And it's great that you don't have to host it and build it yourself, but still this is a lot of work. Then you add to it the complexity that when we talk about mobile games, it's really easy to just make it one thing, but in fact, it's a whole bunch of things, right? Most mobile games are going to work for iOS or Android, or have some sort of mobile component, because a lot of times you get that combo of it's an iOS game, it's an Android game, it's a Facebook game, and you annoy everybody and your friends because you keep inviting them to play. But all that adds extra complexity. And then let's get to the thing, right? When you have something like a game, it's got to work in real time, right? When I turn and shoot at my friend, because that's what friends do, you want it to hit, and you want it to happen in real time. If I shoot at my friend, and then like 5 seconds later, he's like, oh, I'm playing, boom, he's just dead. That was like Quake in the early aughts, right? We don't want that. It might be the 90s, I'm dating myself. But we don't want that. We want a real-time experience. We want things to actually happen for real. So when you add up all this is possible, and you have probably done part of this in this room, not in this room, but you in this room have probably done this at some point, at some part of it. And it's difficult, and it's kind of a pain, and it's a lot of work, and at the end of the day, all of this is not your competitive advantage, right? You have this really awesome idea for a game. You very rarely hear gamers say something like, oh, dude, the mean latency between when I fire and when the guy hits is awesome. That's why I want this game. Like, no, that's not why. It kills it. That, the fact that your game does not work will kill excitement, but none of this is actually what's going to drive your success. So all this is expensive engineering time. So is there a better way? No, presentation over. Of course, we think there's a better way. And we recently, Google acquired Firebase, which is, what's the marketing spiel here? A powerful platform for mobile and web applications. It really is. It really is a very, very cool way of building mobile and web apps. So about three real big features. First being real-time databases is what we're going to be talking about today. Basically the ability to write a very simple client. You write data to it, and it will handle syncing it to all the clients that are also looking at the same set of data. Drop dead simple, and I'll show you code that kind of shows this off. Next piece is user authentication. This is, again, it's not a very, people have done this. It's complicated, but it's doable. But basically, we take this and make this easy, right? You want your app to be authenticated by Google or by Twitter or by Facebook or by custom authentication. We build it in, and it's pretty easy to do. And then finally, we noticed that a lot of people were doing Firebase for their backend, but having to spin up servers to serve static content, because Firebase supports web, it supports iOS, and it supports Android. So on the website, people would set up hosting servers and need CDNs and all that. We basically handle that now all for you. So here we go. We're going to focus on real time, and I'm going to show some examples of real time in action. So the first one being location. This is a big use case. Let me see if I can find my mouse here somewhere. There we go. So location. Unfortunately, we don't have live data. Oh, first off, I'm going to get rid of my Twitter feed because that's dangerous in a presentation. So this is, even though it's 6 in the morning, well, it's 6 in the morning in San Francisco, this is a live rendering of all the buses that are running in San Francisco right now. Now, I would love to have put up London. I've heard conflicting reasons where I don't have London data. One developer said the London data is not really that usable. One other said, what state is London in? Because they're American developers. So this is San Francisco, and that's why I'm showing that off. That's my hometown. That's what I can say for why we're showing that. But this is in real time. As these buses move, you see them moving. And it's 6 a.m., so there's a lot of buses moving, people that are very sad and miserable because they have to be up at work before 6 a.m. And that's location data. Now the next one is a group activity. So if you'd like, please go to tinyurl.com/firedraw. I'll keep that on the stage for a minute. Now this is dangerous, right? You can feel free to draw stuff in front of this, okay? So let's please keep it PG. No, you guys, I forgot what your rating system is. But let's keep it tame, okay? So now that I'm going to click over. Oh, good. See, all of us are drawing in real time, and as I change my ink, wow, a lot of people are drawing. As we do this, real time, those scribbles reveal important information, and you're getting that important information in real time. But all of us are connected to it, and all of us are writing stuff, and that's going to give me a seizure soon. So I'm gonna get it off screen. Someone's erasing stuff. Great. But there's an example. That's real time. Like if we were in a meeting and we were really caring about communicating to each other, we could actually do it, and we do it in real time. The last example I'm going to give is a gaming demo, and I'm going to show you real-time Tetris, multiplayer Tetris, or what I like to call, hey, let's get into a fight. This is real-time Tetris, and you'll see that as I switch over here and I start moving stuff around, I give myself an aneurysm as I try to play both of these at the same time. But we'll see that as I'm doing something on the left, it's registering, and I'm doing something on the right. This is going back up to the server and being communicated down to both clients. It's not running cross-window, it's running up and then back down. So really kind of great example of what we do in real time. So I'm going to talk a little bit more about who's using us, and then I get into code. Oh, I'm sorry, I have some wines. So real time is hard. Real time is really hard. Like to do this, like I showed you this, and those are really trivial examples of doing real time. But real time is actually hard. The first part of why it's hard is that the underlying transport is actually very complex. I mean, we like to think we do sockets or we do web sockets that we're like wiring a pipe, right? And we have this pipe and we send something through and thump, right? Because it's a pneumatic tube in my mind. Thump, and there it is, right? But that's not really what's happening. Under the covers, IP is, of course, breaking that information into packets and sending along, and it's doing breakages, and so it's reassembling it at the other line. And so keeping that all in a real-time transport is very, very difficult. And then add to it that we have unreliable networks, right? I don't know, my favorite example of this is at Google headquarters in Mountain View, we have buses that take people to their houses and cause lots of trouble with the locals, but they all have wireless on them. And the amount of times I've sat there, been on my phone, and then like the service just goes away, and I can see the bus leaving. And I realize that I'm connected to that bus, even though there are like 5 buses around that all have wireless, but that was the bus that my phone was connected to. You do this all the time. You walk out of a place, you have a little bit of you have a little bit of Wi-Fi signal, and so that trumps the fact that you're like outside trying to get through concrete, and that LTE would actually be the better thing to get. These sorts of things happen, and writing programs that handle these use cases is incredibly complex and incredibly difficult. Add to it that you don't get to do it just once, right? Because you're going to do it once for iOS, because you want to sell stuff, once for Android, because you have to, and then once for web, because we might as well make it for everybody, and there are other ways to monetize it, right? So now you're doing the same thing 3 times. You're doing the same difficult job 3 times. So real time is hard. So okay, so who's using us? Well, real quick, after this, I promise there'll be code. So CBS. CBS has a show called Big Brother. Some would describe as the end of civilization, or a reality show, take your pick. And they wanted to have real-time chat among their users. So they built a real-time chat that handles 27,000 messages per show and 50,000 concurrent users per show. That is a lot of communication about Big Brother, and that scares me. But this, you can't deny that this is powerfully done, that this is a large amount of people that are talking at once. So that's CBS, and that, I like them, like CBS is gigantic, right? They're a huge multi-country conglomerate, you know. On the other end of the scale, we got a startup. How many people here have ever done like I won't say done. How many people here have ever heard of role-playing games like on the table and the dice and stuff? Just heard of, right? No one here actually ever played it, right? All right, I'll own it. I totally did. So a bunch of friends got together and said, we would love to keep doing this, but we all live in different parts of the U.S. and we just can't. So they got together. They put together a Kickstarter. They raised $40,000, and they have now grown to 100,000 users. 100,000 users sit around at computers and simulate being at a kitchen table and playing with their friends. And that's hugely powerful. The friendships that get driven from these sorts of experiences are really powerful, and to be able to tie into them and use this software in order to do that is awesome. Oh, and by the way, these guys, 1 engineer. So they support all of that, 100,000 users with 1 engineer. And they've said that being able to like just the plumbing is all Firebase. We can work on front-end features. Saves them. Like they don't have to have more than 1 engineer. And by the way, the 1 engineer wasn't really like an engineer before he started. He like took he was the one of the group that had comp sci in college, and so he got stuck with doing the programming. So okay, so over 20,000 developers, companies you may have heard of like Atlassian or InVision or Twitch or Tweetwall or Citrix. All these guys are using Firebase. All right, now we're going to get to a demo. So we're going to do a live demo. Go to this URL, and I'm going to talk through the code base in a bit. So the URL is mmo-asteroids.firebaseapp.com. It's kind of cool having a long URL as a limiting factor, right? We can't get too many people in because the URL is long enough that it's going to weed some of you guys out. So I'm going to leave that up for a second and show on the screen everybody playing multiplayer Asteroids. So the story behind this is April Fool's Day a while back, somebody came up with the idea of, oh, we have a multiplayer Asteroids. And they were waving their hands for some reason. And they did this, and basically the joke was you went in and you played for a little while, and then all the bots that were in it, because it wasn't really multiplayer, would like team up against you and destroy you. Hilarious. So Firebase said, like that's not hard. We could just do that. right? We could do a multiplayer asteroids. And in fact, if I go in here, we should see, whoa, this is awesome. This is so many people playing asteroids. I got to try it. All right, sorry, I will get distracted. All right, but so yeah, that's how long I lasted with that many people in. So every one of these represents probably someone in the room, I hope, who is playing asteroids and beating other people and keeping track of it. So we wired up Firebase to do this. Now, the original asteroids game was about 1,400 lines of code. We stripped out the actual asteroids and just made it ship versus ship. And then we took the asteroids code and basically did what we need to do to make it real time, to be multiplayer. And it took about 30 lines of code that are Firebase specific. And as I take you through the code base, anything in bold is absolutely something that was Firebase added, and anything not in bold was like existing stuff. So there's 1,400 lines of code that's like physics engine and collision detection and all that, and the 30 lines of code make it real time, and that's what I'm going to take you guys through. Okay, thank you guys for logging in, and I hope I didn't lose too many of you to the game. So this is how you start off with Firebase. You'll see that I do a reference to a Firebase URL, and then I create a child of it, and that child is game. There are multiple children. There are multiple children of the high-level Firebase, and one of them is the game, one of them is the leaderboard, one of them I can't remember because I'm in front of people and now I can't remember things. But the game is where all of the ship information and all the bullets and all the real stuff is. So that's the only piece of it that I've gone into. Next, I get a reference to a Firebase object. So you see I add a child to it, and I push it to an array of players, and I get a reference back, and then I also set another reference to say if the person drops out, remove their ship. Then what I do is I say, okay, on that ship, here's the details of that ship. And so I do this every keyframe. So a lot of chatter back and forth to Firebase. But I basically manipulate and say, this is what its acceleration, this is its XY, this is its heading, this is its rotation, and this is whether or not the person is pressing the button to accelerate it. So I write that every keyframe. And then every time somebody joins the game, I add a record to my local client to keep track of that enemy, right? And then every keyframe, they change their data, right? Because every keyframe, they're doing exactly what I do, which is I set all my data every keyframe. They're setting all their data every keyframe. So on everyone else's keyframes, I'm downloading, I'm listening for their updates. Then I also handle removal. Sorry, I'm going to make this full screen again. Sorry about that. I handle removal, which is enemy ships getting blown up, which makes me happy. And so I do an explosion and handle that with the game. I also have to track bullets, right? And again, with bullets, there's a little less data. It's just X, Y, and vector, velocity, which is speed and trajectory. Then I have to deal with tracking collisions with enemy bullets, boo, and then enemy removal, yay. And that's it, right? That's all it took to get that game to be real time. Just all those little references to Firebase, and that's it. So, any questions on that before I move forward? No one has stopped for ask for questions, but I'm going to. Yes?
Somebody joins when the game's in progress, so is it caching all of that data to give them a snapshot of what they've missed? If you like, so it only send
Yes. Yes. So what happens is when you join, it's actually. Oh, sorry. The question was, when somebody joins, is it caching all that data so that you get a state when you join? And the answer is yes, it does. What happens is when you join, it's doing a child added for all the records in the player database. So it's not doing a cache. It's just taking the existing state and dumping it into your client, and then your client handles adding all of them to the existing setup. And then then it takes over from where it was, updating on every keyframe. Any other questions? That was a great question. Yes?
If you're updating on keyframe, what kind of volume are you pushing?
The question is, if you're updating on keyframe, what kind of volume are you pushing? I think in metric, you'd say a crap ton. It's a lot. It's a lot of chatter. And so there's a little bit of stutter, if you notice. That's actually visual rendering stutter and not network communication. Basically, we had a choice of which to polish, and we polished the network, and we did not polish the visual stutter. But yeah, it's pushing a lot of data back and forth. And from a data perspective, it's not a tremendous amount of data. It's like, it's 10 lines of JSON that, is like a byte maybe. Not a byte, but a couple bytes. And so it's pushing it back and forth. So yeah, the actual bandwidth is not that high, even when you get a huge number of, it's just rendering all of that out. Gets a little taxing. All right, I'll take one more question, then I'm going to move on. Any other question? Yes?
In the case where you switch between networks, does it send you the things you missed when you were disconnected?
That's a great question. It depends. So the question is, in the case of dropping a network and then rejoining the network, will it send you what you've missed? And the answer is, it depends. It depends on the way you architect things. You would have to write because right now when you disconnect, it just drops you out of the game, because that's the way we wrote it, like that one line of code says drop out. If you wrote it so that you continued the state when someone dropped out locally and then joined up, you'd have to write some rules to handle when things aren't aligned. But you could do that. It would just become much more complicated than a very simple. And with a game like this, you wouldn't do that, right? Because running it locally, so much other stuff, like Heisenberg and all that, right? Like it would break computing to do that. But for a less chaotic game or less chaotic situation, you absolutely would do that. You just join, and all of the children, you basically reset the state, and everything would come back in. Okay? All right, cool. So that is an example of MMO, building an MMO with Firebase in real time. But it doesn't handle all the use cases. What happens if you only have one player? I've done it. It's really sad and lonely. You just fly around and shoot, nothing's there. So it would be cool if we could build AI into it and build, individual AI bots into it. The problem with that, though, is that if I write them into the clients, then that gets really confusing. So what happens if somebody joins? What happens to that bot? If that bot lives on the blue phone, do I transfer it to the red phone, and do I keep transferring all that data? And what happens if the person that owns the bot drops out? Does the bot go away? So it becomes kind of difficult. So you wouldn't want to write a bot into that. There's other reasons why you would want to plug into a Firebase and do extra processing. One of the other examples they can come up with is the idea of a warden server, right? So you've got this game, you've got people that really care about it, you've got a leaderboard, people are going to cheat. So you want a warden server to detect whether or not people are cheating and boot them off if they do. Now, Firebase does not have the ability to do extra processing. I can store data, I can get data out, but I can't really manipulate that data once it's in Firebase, right? Like that's not a piece of the Firebase offering. But what I can do is I can add an extra client. Now, in the case of the phones, right, we're kind of cool. We're using the phone clients. But for this extra server, we have a web client, right? We have a JavaScript-enabled client, so I could run Node.js, hook that up in a server, and run that as a client of the Firebase. So now I can build anything I want into the server, have it listen to the entire Firebase, and act accordingly. And just so happens, I work for a company that can provide virtual machines or other types of processing. So I'm going to show an example of doing this with Compute Engine. Now, depending on your needs, you could do this with Compute Engine, or you could also do this with App Engine. For the purposes of the bot, it makes sense to do it with Compute Engine. So I'm going to do it with Compute Engine. If you're asking why, it's because App Engine is awesome, but its request time, the most a request can last is 60 seconds. And the idea is like, you're handling API stuff. If you can't get it done in 60 seconds, you need to scale out. But with something like this, I've got a bot that's continuously running. I need it to run for more than 60 seconds. So Compute Engine gives me the ability to do that. So I'm going to run a Compute Engine. And now I'm going to show this app with bots. So I don't know if people are still in. If you're in, okay, good. Good. No, don't come in. Or you can, but it's not that big a deal. Because robots are going to destroy you in a second. So I have here, you'll see here I have 5 VMs. I'm going to start one up. Start. And that's going to take about 30 seconds, at least in worst case scenario, which I totally assume is going to happen. All right, so people are in there, but not too many people. And I'll show the code while we're waiting for it to set up. Let's see. So the code for this guy is here. This is the bot AI. Basically what it does is I'll put it on full screen while we're waiting for that to set up. Hold on. But basically what it does is it takes a random number and then makes a decision based on what that random number is. Basically it turns right or it turns left and shoots. And then I think there's one, I think I might have cut off a line where it also will turn on the engine and engage for a little bit. So that's a very, very simple AI, and I'll explain after I show it in action. Let's see, hold on, did it launch? Yep, that appears to have launched. So if I go back here, you'll see right here, that guy, that's a bot. That spinning guy is a bot, right? You'll see he's just sort of making weird decisions and driving into stuff and blowing up because he's not that smart. Now I'm going to go one step further, and so I'll do one more here. So I can do bot. This is the great thing about VMs. I can just clone this guy. And that's what I've done. So I need some help. I need some more bots. Great, I'll clone them. That's going to take another couple seconds. So while I'm waiting for him to start up, I'm just going to start up everybody, right? And I'm going to turn this into a slaughterhouse, right? So why is my AI code so basic, right? It's just random. Because a very brilliant woman by the name of Jenny Tong wrote this demo. And so her first pass, she did that one. She just wanted to see if she could make any AI, like what she had to do to take out to make it work, right? And so she got that AI working, and she's like, all right, I'm going to go one step further. And instead of going one step further, she built it so well that like you would spawn in, it would do the trigonomic functions to figure out where you were, and target you immediately. So it was literally like you'd spawn in, dead, spawn in, dead, spawn in, dead, game over. And we didn't really have time to like, hey, Jenny, can you dial it back just a little bit so we can have some fun playing? So we just decided to leave the random one in because the random one is kind of fun and it shows it off. And if you get enough of them in, see all the guys that I started up are all now running. And there's one, that guy, the yellow Twitter head right there, is still playing. God bless you. So that's, now I have all the kill bots going. Now, how hard is this to do? It's not really that hard. So what I'm going to do is I'm going to spin down all of them. I will stop. And then I'll show you the process for building one of these machines. Now, keep in mind there's a little bit of development time. We did some work to make this so seamless, but it really is, once you kind of get your script ready, it's going to be this seamless. So I'm going to go here to Cloud Launcher, and I'm going to maximize the screen here. There we go. So Cloud Launcher are a whole bunch of already built OSs and software packages. There's some from Bitnami who were tweeting. I think they have some presence here. But basically, I am going to go and say Node. Right? You'll see I get a whole bunch of them, and I'm going to go with this one, Node.js. Right? So that's all it is. It's just Node.js. And you'll see I get estimated cost for if I run it on this and I have persistent disk and it's running all of the time, this is how much it's going to cost me a month to run, which is really kind of helpful. It helps me plan out things. And so I'm going to get started. and I get this screen, and I got to put it in MMO asteroids bot. I'll hit continue. And now I can go through and customize the VM I'm building. I can change the specs. I can add, I can go processor high. Like if I wanted, I don't know why you would need 32 processors and 208 gigs of memory for this guy, but you could do it if you wanted. It would, I don't know. I don't think it would really do anything. But what I'm going to do here, here's a special sauce of this. I'm going to go here into GitHub, and this is the script that we use to run these. It's a startup script. Basically, whenever the VM starts up, it's going to run, it's going to set the path to Bitnami. It's going to pull down the Forever package from, for Node. Then it's going to clone the asteroids project. Then it's going to go into the bots folder and install the bot project and run it. So that's basically all this thing does, right? So I copy and paste this. Okay. Hold on, where did that window go? Okay, I copy and paste that into startup script. I'm sorry if it's really small. I just realized that, I apologize. But, you know, it's just the startup script basically. And before I start this up, I just want to look here and we make sure that none of the bots are running. So I'm going to create a new one. So I'll create that. And you'll see it's going to deploy Node.js. And let's see. It's going to take about 30 seconds, which on stage feels like it's forever. But, you know, we're creating the instance. It's pulling down that Node image. It's building the machines based off of it. It's going to start it up soon. Any other trivia I can go over on this? So I think that, by the way, this is the most I've ever seen multiplayer of this game. So thank you guys very much for participating. That was awesome. Let's see, where are we? Oh, okay. The solution is starting. Come on. So while this is waiting, any questions? You see the script again? Oh, you mean the actual, I'm sorry, the bot script? That one. Yeah. Zoom it. Yep, 16 lines of script, just to run that. So basically, it's, like I said, it's pulling it down, it's cloning the Git repository, and then it's installing the bot.js file into Node, and then it's running forever start that bot, so just running it on a continuous loop. Okay? All right, let's see, is this done? Come on. Done, yeah. Now I can go in and manage it. I love this. I can SSH directly into it, right from the browser, which I absolutely love. All Compute Engine, you can just do that. You just SSH directly from the browser. No certificates, no nothing. Like I didn't do anything special. It just, we wrote it that way. And I love our engineers for having done that, because I hate SSH keys. All right, so there we go, and there he is. There's our guy that we added, because we got rid of everyone else. So in real time, in front of you guys, in under a minute, we added from scratch, by pulling down from GitHub, we started our own bot. What do you guys think of that? Is that cool? All right. So that is Firebase in action. I'm going to end here with a couple conclusions. So, right, in this day and age, I don't think it is shocking or surprising to anybody to make the statement that mobile is important, right? And I focused on games because, like I said, it's a really easy way of showing multiplayer. But there are lots of use cases for real time that go beyond gaming. I showed chat. InVision does a really great job of doing real-time design comps. So they put up UI screens in front of people, and they have meetings where people can real-time mark them up, sort of a combination of chat and the drawing app I showed. And the list kind of goes on and on of what you can do once you're limited. Once like worrying about real time goes away, it becomes really easy to implement and just do. So mobile's important, real time is important, but a lot of it becomes an infrastructure task. And that infrastructure, while again we appreciate your business, is not valuable. It's not a great way of spending your time because your competitive advantage is coming elsewhere. It's coming from the creativity and vision you put into the front part of your app and not the plumbing. So Firebase, so this is traditionally complex. Firebase seeks to get it here back to where we started, back to your managers and VP's idea of what the cloud is, just a giant blue box into which you put things and it just handles it for you. We really try to get there. And at the end of the day, if you need more processing power, it's really easy to hook up multiple solutions to be either a client for your apps to run and talk to, or a client of Firebase. I mean, either way you could do and talk to them and extend your apps. So if you guys are interested, check out firebase.com. There's a free account, and the free is cost is based on concurrent user. So while you're trying up the idea and you're just trying to figure stuff out, if you have less than 50 concurrent users, it's free. And then after 50 concurrent users, and again, it's concurrent users, not total users, but concurrent, so all at the same time. After 50 concurrent users, we talked to you about pricing, but it's sort of reasonable, right? Like you can experiment and actually grow a business to a really good point on 50 concurrent users. So with that, I'll say thank you guys very much. And there's a break after this, so I'm going to stick around here for a while. If you have any questions, feel free to either ask me or go, and I'll stick around here, and you can come up and ask. All right? Thank you guys very much.